Welcome, students, to Solving Rational Equations Algebraically, which is on page 6 of your notes. So in order to solve something like this algebraically, we have to get common denominators before we can do anything like reverse PEMDAS that we're used to. So let's first get a common denominator for all the fractions. Now in this one, two of my fractions already have 6x squared in the denominator, and this poor little guy doesn't. But all I have to do is, well, 2 times 3 will give me 6, so go ahead and multiply by 3. And then x times x would give me x squared, so multiply that by a 3x up here too. So my first fraction is 1 over 6x squared. Nothing changed there, same thing. Now I'm going to take 3x times 1, which is 3x. And this is 3x times 2x. Minus, and then just copy the last one because I didn't change it. Go ahead and put that in parentheses, and I'll show you why in a little while. All right, so one more step here. 3x over, now 3x times 2x is 6x squared minus parentheses x plus 7 over 6x squared. Okay, so my denominators are equal. Yay. Once you get all your denominators equal, you can temporarily ignore them and just set the numerators into a fraction. So into an equation, rather. So I'm going to take my numerators here and just make an equation out of them. So 1 equals 3x minus x plus 7, just like that. And now I'm just going to do reverse PEMDAS on them. But first, go ahead and distribute that minus. So 1 equals 3x minus x minus 7. Okay, now I just have to solve it like usual. So first, I have, let me switch back to my other color. I can combine these two guys because they're like terms. So 1 equals 3x minus x is 2x minus 7. And then I need to add 7 to both sides. Then divide by 2. So I get x equals 4. Now, remember with a rational function, we've got these denominators that have x's in them, and denominators can't be 0. So before you decide that's the answer, plug your solutions into the denominator to make sure you don't get 0. If you do, it is an extraneous solution, which you may remember from Unit 6 when we did square roots. If you do get 0, it's extraneous. So let's make sure it's not extraneous. So take your denominator. So I'm going to check my denominator, which my denominator is 6x squared. And I'm just going to plug 4 in. I'm going to plug 4 in for x right here. So 6 times 4 squared gives me 96, which yay is not 0. Yay. So my solution is x equals 4. Let's try the next example. So on this one, I need my denominators equal. So notice I have 4b squared, and then I have 2b squared and 2b squared. All I have to do is multiply these guys by 2. And then they'll be equal. So let's see. b plus 6 over 4b squared plus, now 2 times 3 is 6, and 2 times 2b squared is 4b squared, equals, then 2 parentheses b plus 4 over, again, 4b squared. Cool. Now, once my denominators are equal, again, temporarily, I get to ignore them. Just temporarily. And I can make an equation out of the numerators. So b plus 6 equals 2b plus 4. And then first, let me go ahead and take care of that right there in this. So b plus 6 is 12. And then here, 2 times b is 2b. 2 times 4 is 8. Just like that. Now remember, when you have a b on both sides, you have to get rid of one of them first. I'm going to choose to get rid of this one, but it really doesn't matter which one you get rid of. It'll work either way. And 2b minus b is just b. And then finally subtract 8. So b equals 4. Now remember, you're not done yet. You have to check that denominator. So check the denominator, which is 4b squared. So I'm going to take 4 and I'm going to plug 4 in for b squared. And 4 squared is 16 times 4 gives me 64, which is not 0. So my solution is b equals 4. Yay! And our last one. So we've got 1 over x equals 6 over 5x and then a 1. So first of all, sometimes if you see a whole number there, go ahead and put it over 1 so it looks like a fraction. Then let's go ahead and make all our denominators 5x, because this one I just have to multiply by 5, so that's easy. And this one is just going to be 5x over 5x. So I've got 5 times 1, that's 5, over 5 times x, that's 5x, equals, and then this one stayed the same, and then plus, and this is just 5x over 5x. So now that my denominators are the same, I can temporarily ignore them and make an equation with my numerators. So I have 5 equals 6 plus 5x. Then I'm going to subtract 6 and divide by 5. So x equals negative 1/5. And again, do check that denominator. Check denominator, which in this case is 5x. So I'm going to plug negative 1/5 in for x right here. So I have 5 times negative 1/5, which gives me negative 1, which is not 0. So I know my solution is indeed x equals negative 1/5. Yay!